In section 3.5, we're going to talk about tree and Venn diagrams. So tree and Venn diagrams are used to visualize the probabilities and to also solve the probabilities. So a tree diagram is a type of graph that you can use to determine the outcomes of an experiment. It consists of branches, and you can label these branches as either frequencies or just probabilities. So say we have a jar and there are 11 marbles. 3 marbles are red, 8 marbles are blue. Draw 2 marbles one at a time with replacement. So this is going to be independent. Okay, now I can, this whole first box right here is your first draw. The second box is your second draw. So the first box is your first draw and the second box is your second draw. Now, once you start right here, you have a choice, 8 blue or 3 red. So we could write, I have 8 out of 11 marbles or 3 out of 11 marbles. Once I get here, so say my first one was blue, I have another choice. I put that one back, and then I can either have a blue or a red. So same thing. Because I put it back, I still have 8 blue over 11. I still have 3 red over 11. Same thing over here. If it happened to be red, I still have the exact same probabilities. Now what I'm doing is, if I take this 8 times this 8, that gives me 64 blues and then blues, so I'm multiplying. Or this 8 times this 3, 24 blue first and then a red. 3 red, 8 blue, 24 red and then a blue. Or 3 red, 9 red and then a red. Okay? We can also label this as, we can take the 8 over 11 times 8 over 11. That would give us 64 over 121. Or the 8 over 11 times 3 over 11. That would give us 24 over 121. Or the 3 over 11 times the 8 over 11. That would give us 24 over 121. Or the 3 over 11 times the 3 over 11. That would give us 9 over 121. So you can use either just the frequencies or you can use the probabilities. Now for this one, calculate the probability of a red and then a red. Okay? Now these are going to be independent. And you can notice that here, if I, well actually you wouldn't notice there, it would say in the problem that this is independent or without replacement or with replacement. But right now we're going to assume that's independent. So we're going to go down this route. A red, pick this one up, and then a red, pick this one up. So 9 red out of red. I could add all of these together. That would give me my sample space. Just like it would here. If I added all of these together right here, that would give me 121. Or I could put the probabilities on here and take a 3 over 11 times a 3 over 11, which would give me 9 over 121. And that'd be my final answer. A red or a blue and then a blue and then a red. Well, first I need to figure out a red and then a blue. So a red and then a blue, that'd be 24 over 121. Probability of a blue and then a red, say blue and then a red, that'd be 24 over 121. An OR probability is talking about the addition rule. So probability of a red and then a blue or a blue and then a red means I'm just going to add these two together to get 48 over 121. It says probability of a red on the first draw and a blue on the second draw. That's the exact same thing as writing a red and then a blue. This is what you're assuming. You pull a red out on the first draw and a blue out on the second draw. So a red and then a blue. Well, that would be, if we label this 3 over 11, 8 over 11, we'd have 3 over 11 times 8 over 11, 24 over 121 would be our final answer. Okay, the probability of a red on the second draw given blue was first. Okay, this is saying, okay, we have already got to this point right here. We drew a blue. What's the probability at that point of getting a red? Well, we would have here 3 over 11. Since this is independent, this is really just looking at the probability of getting a red, which would be 3 over 11. Okay, probability of a blue and then a blue, so a blue and then a blue, I'd have 8 over 11, 8 over 11. So 8 over 11 times 8 over 11, 64 over 121. Okay, now we go throughout this and do this without replacement now. Notice how, okay, with the first draw, 8 over 11 if it's blue and 3 over 11 if it's red. But on the second draw, say I got the blue first, well now I don't have 8 blues anymore, I have 7 blues. I don't have 11 marbles, I have 10. Okay, we still have the same number of reds because we took out a blue, but because we took out a blue, we only have 10 marbles. Same thing over here. I took a red out first, so I still have 8 blues, but only 10 marbles. Because I took a red out, I only have 2 red marbles left out of 10 marbles. And you would still multiply, like we did in the other one, 8 over 11 times 7 over 10 to get the 56 over 110. And you can use probabilities or just frequencies. If we had just frequencies, we wouldn't have any of the bottom numbers right here if it was just frequencies. In order to get the bottom number, you would add all of these right here and you would get 110. Okay, probability of a red and then a red. Well, a red, grab this one, and then a red, grab this one. It will be 6 over 110. That's it. Probability of a red, then a blue, or a blue and then a red. So this is an and probability. The whole thing is an or probability. So a red and then a blue, that's going to give us 24 over 10. So 24 over 10 plus, okay, blue and then a red, that gives us 24 over 110, so 48 over 110. Okay, probability of red on second, given that blue was on the first. So we took this route here, and now we're at this point. So what's the probability of getting a red on the second try, given that you've already taken out a blue? Well, it's just that right there. Okay, the probability of a red on the first and blue on the second, that's just the same thing as writing this right here. So red and then a blue, 24 over 110. Probability of a blue and then a blue, so blue and then blue, right there. 56 over 110. Okay, let's talk about a Venn diagram. So it's just a picture that will represent the outcome of the experiment. So like this right here. If we've got outcomes that go from 1 through 12, and we say event A is 1 through 6, event B is 6 through 9. Notice that we left out 10, 11, and 12. Okay. Also notice that what's in common is a 6, and if I combine all of them together, it goes from 1 to 9. Okay. So in A, just A, I've got a 1, 2, 3, 4, and 5. In B, and you've got the 6. In B, you've got the 6, 7, and 8. What's common or overlapping between the A and the B is the 6. That's why it goes in the middle there. But 10, 11, and 12 didn't go into A or B, so it's just in this box, and we call that the sample space. And that's just everything together. Okay, so out of 40 students, 14 are taking English Comp and 29 are taking Chemistry. If 5 students are in both classes, how many students are in neither? Okay, so 5 students are in both classes, so the 5 will go right there in the middle. In English, we've got 14. So 14 minus 5, 9 left. 29 minus 5 is 24. because this whole thing right here is chemistry. This whole thing has got to add up to 29. We don't want to count the 5 twice. Okay, so if I do 9 plus 5 plus 24, that gives me 38, which means there are 2 students that are in neither English or chemistry. How many are in either class? Either English or chemistry? Well, we just did that right here. That should be 38. What's the probability that a randomly chosen student from this group is taking only chemistry in this class? Just chemistry, okay? So there are 24 that are taking just chemistry. So 24 out of 40 students, that's going to give you 0.6, or, well, that's it. They didn't want percentage. So 0.6 would be your final answer.